Okay, so for today we are going to discuss the inequality that involve the modulus function or modular sign. Okay, so in the previous video we already learned how to solve the equation. Equation means got equal sign. Alright, so for today's lesson onward we are going to learn the inequality for the modulus function. Okay, so for inequality that involve the modulus sign, generally you need to know a few important concept. Alright, so these are the 4 important concepts that you need to know. Okay, so the first one is when modulus x smaller equals to a is a number. Alright, so when modulus x smaller equals to a, it actually means that the x is between negative a until a. Alright, so this is a result which is very important and you will use it for solving the inequality later. Right, okay, so you need to memorize it. Okay, so when we are having modulus x smaller equals to a, why is it the x is between negative a until a? I think we learned this one before in statistics 1 also, right? That normal distribution involve the modular sign. Okay, so this is how we write out the equation. Okay, so maybe we can take one example. Alright, so when we say that x is smaller equals to 2, let's say, as an example, alright, let's say a is a 2. Okay, so we can actually try and check and see what is the value of x, so that when you put in the value and you take the modulus, it is still smaller and equals to 2. You can try an error. So as an example, you can try. If let's say x equals to negative 3, so when you put 3 here, you become modulus 3. Modulus negative 3, which is a 3. So 3, is it smaller equals to 2 or not? No, right? So that means negative 3 shouldn't be the value that put into this inequality. It is not true for this inequality. Alright, then you can try. Let's say I'm having negative 2. Okay, so when x equals to negative 2, you put it inside, it will become 2, right? Okay, so 2 is smaller or equals to 2, which is true. Okay, so maybe better I draw it. Okay, so when they say x smaller equals to 2, I would like to try a few values. Okay, so just now I tried for negative 3. Negative 3 is not the correct answer. Okay, then when you put negative 2 inside the inequality, it is correct. The inequality is correct. So that means negative 2 is one of the answers that fulfill this inequality. Okay, then next one, you can try negative 1. So if you put negative 1 into this equation, this inequality, okay, so negative 1 modulus is a 1, right? So 1 smaller equals to 2. That means this is still true when you put in negative 1 into the inequality. So negative 1 is part of your answer. Okay, and then what happened to 0? So next value, if you put in 0, so when 0, modulus 0 is still a 0. So 0 smaller equals to 2 means it's also still a correct answer. Next value, you try 1. So when you put in a 1, 1 is smaller equals to 2. It is also the correct answer. 2, when you put it inside this inequality, 2 smaller equals to 2. That means this inequality is still correct. And then when you put the 3 inside this inequality now, so you have 3 smaller equals to 2. That means now this inequality becomes false if you put the value 3. You can try further, alright? So if you put 4 also, 4 smaller equals to 2, which is not true also. Correct or not? So that means all the 3, 4, 5, 6 and so on will not be the correct answer. So the correct answer are only from negative 2 until 2. So when you want to write out the answer, it will become negative 2. That means the x should be between negative 2 until 2 only. So if you compare it with this inequality, you can write it out like this. X is between negative 2 until 2. So that's why we have this inequality. So that means you need to memorize the result. Modulus x smaller equals to a number, and then x is between the negative number until the positive number. So as an example, x is smaller equals to 2. Then when you write it out or expand it, it will become x is between negative 2 until 2. So the concept actually comes from this number line. Alright, by try and error. So you can use some very simple numbers to test your understanding. If let's say you don't really understand the equation of inequality. Okay, so when you want to apply this result, there's one important thing that you need to know. The A must be a positive number. Okay, that only you can use this result. All right. Okay, then now we proceed to the second important information. Okay, when A is still a positive number, modulus x greater equals to A, you can write it become x smaller equals to negative A, and also x greater equals to A. Alright, so what's the meaning? So again, if you want to verify and clarify the result, to understand the result, maybe you can one simple example here. So let's say I'm having modulus x greater equals to 3. 3 is a positive number, right? They are requesting for positive number. Okay, and again, you can try any other numbers now, alright? So negative 4, negative 3, 2, 1, 0. Then you have 1, 2, 3, 4. You can simply take a few numbers to try out and see. Okay? Okay, so you can start to put in the value one by one. Okay, so you can start with negative first. When x equals to negative 5, put it into this inequality. Negative 5 modulus is a 5. So 5 greater equals to 3. This is a true inequality, right? So that means negative 5 will be one of the answer. Okay? And then how about if you put in negative 4? So if you put in negative 4, modulus negative 4 becomes 4. So 4 greater equals to 3. It is still true. So negative 4 is also one of the answers that fulfill this inequality. Then when you put in negative 3 here, so if you put in negative 3, so that means become positive 3. So 3 greater equals to 3. It is still true. Okay, next one. If you put in negative 2 into this equation, it is inequality. So negative 2 modulus become 2. So 2 greater equals to 3, which is not true anymore. So the same thing happen, you put in negative 1, you put in 0, you put in 1, and you put in 2. All these numbers will not give you the correct inequality. That means didn't fulfill the inequality here. Until if you put in the value 3 again, the inequality becomes true again. Alright, so 3 greater equals to 3, this is true. When you put in the 4, 4 greater equals to 3, it is true also. And then when you put in 5, so that means 5 greater equals to 3, it is true also. If you continue to put in the 6, 7, 8, 9, and 10, and so on, you will realize that all are true. Okay, so from this number line, you can actually conclude that the correct answer will appear at the sides. So for this part, when you write out the answer, it should be x smaller equals to negative 3. And then for this part, it will be x greater equals to 3. So if you compare to the result, okay, so that means when you are having modulus x greater equals to a, you can write it become x smaller equals to negative a, so x greater equals to positive a. So these two are very important results that we are going to use it quite frequently in the exam later, or in the exam style question later. So you have to remember these two results. Okay? Alright, then again, to apply these two results, you have to make sure that the value of a must be a positive number. Okay, then how about if let's say we are having a as a negative number here. Okay, so we can discuss this. When you are having a with a negative number, so that means modulus x smaller equals to a is impossible for all the x. Alright, so what does it mean? Okay, so we can just try to understand it by using some simple example. Let's say modulus x smaller equals to negative 1, let's say. Okay, so for the number line, you can try a few numbers that you like. Okay, so usually, maybe I try from negative 3 until 3. Okay, so you realize that no matter what kind of value are you putting in here, okay, it is always not true. So that means there's no number that fulfill this inequality. Okay, it is impossible for you to have any modulus value x which is smaller or equals to negative 1. So that means when a is a negative number, right, this modulus function has no solution. Okay, so that's why you say you will see that impossible for all the value of x. That means no solution for x. Alright, so that's the meaning. Okay, so again, this one is concept-wise, so we seldom use it in the exam. Okay, the first two we use it quite often. So this one is concept for understanding. Alright, okay. Then how about if let's say you are having A is a negative number, then what will happen for modular x greater than A? Okay, so again, maybe you can try. So let's say now I'm having modulus x greater equals to -1. Okay, so again, you still can try all the numbers that are on the number line. You can try a few by using common sense only, all right? So now, if you put in -3, it become modulus -3 become 3. So 3 is greater equals to -1. So this is a true correct value. So if you continue to every single value later, you will see that it is always true. Even if you put in 0, so modulus 0 is a 0, right? So 0, is it greater equals to -1? Yes. So even 0 is also the correct value. Okay, that fulfill the inequality. 1 also, 2 also, 3 also. So if you continue trying a few numbers, you'll find out that all the numbers that you put in are always true for this one. So that's why the conclusion is what? The modulus x greater equals to A is valid for all the value of x. So this one is no solution. So this one is all the value of x are solution. Okay, so these two last two important points here are mainly for concept. We seldom test students about this in the exam. Okay, and then the first two are very important. Alright, so the first two are very important. Generally, you need to memorize the result here. When you're having modulus x equals to A, and also modulus x greater equals to A, then how are you going to write out the result correctly? Okay, so these two will be very important. Maybe you can put a few stars here. Okay. All right. So now we continue further to see how are we actually going to solve the inequality with modulus function. Okay, so again, you will see that in our notes here, to solve inequality that involve modulus, there are also a few methods that you can use it. So you still have graphical method, you still have definition of modulus. Again, so for us, we can write as non-modulus form. Okay, and then square side. All right, so for square both sides, so you'll see that generally the idea is still the same like what we learned before. Okay, all right, so again, that's why I said different methods will be suitable for different types of question. Okay, so now, before I start with the example 4, right, so again, I will want you to have a look for all the patterns. So first pattern, again, we are talking about one side got modulus, the other side got no modulus, but only with a number. So these two are pattern number 1. Okay, one side got modulus, the other side no modulus, but with numbers only. First pattern. Okay, second pattern will be C and D. Okay, so C and D, what do we have? Second pattern is one side got modulus, the other side no modulus, but with x in it. Same thing happen for this one. Okay, so for part D, right, you need to do some adjustment first. So you make it become x smaller than 3x minus 2. So again, it belongs to pattern number 2, where one side got modulus, the other side got no modulus with x. So they belong to second pattern. Okay. All right. Then the third pattern is both sides also got modulus. Okay. All right. So we are still having these three patterns here. All right, so for the example later, I'll show you a few examples. Maybe I will show you ACE, and you try BDF again. Okay, and then for this inequality, I'm not going to show you all the methods anymore. So what I will show you is the graphical method and also the method that I think is most suitable for me to use in the exam. I'm not going to discuss all the three methods anymore for every single example here. Okay, but I will show you the graphical method and also the method that I usually use in the exam. Two methods. All right, so graphical method to me, again, it is good because of you can understand it very well. Okay, your solution from the graphical method. Okay, then the best method usually is easy, but you can't really see the concept from the method. All right. Okay, so we'll discuss all this in the next video.